Okay, I'm going to work through the solutions now for your practice test. Now, anytime that you guys need to here, you can pause this, especially if I kind of go too fast, or if you need to watch one a couple of times, you can do that. Now, when I'm done, I should be able to put this on YouTube for you, and I'll send you a link in your email. And like especially tonight here, if you want to watch this or a particular problem on YouTube, you can pull that up. Now, let's look on, so on the first one and the second one here, you're adding and subtracting rational expressions. So the idea is what I have to do to be able to combine these two things together, since they're fractions, I have to get a common denominator. And so notice this is not an equation. I'm not looking for what x is. And so since it's an equation, I can't just multiply by the common denominator. I have to get to the common denominator. So they're both binomial factors, and there's nothing in common. So the common denominator is just going to be both of those. It's just going to be x plus 5 times x minus 5. Okay. Now, what I have to do is modify my numerators now. So when I go here from x plus 5 to have an x plus 5 times x minus 5, that means I had to multiply the denominator by x minus 5 to get there. So I'm going to have to multiply the numerator by x minus 5. Okay, so when I do x minus 5 times x minus 5, I'm going to use my full method here. And so that will give me x squared minus 5x minus 5x. I'm just fulling that out. And then negative 5 times negative 5 would be positive 25. Okay, now let's do the other part here. So on the other part, we've got x minus 5, and then we're going to x minus 5 times x plus 5. So to make that happen, we would have had to multiply the denominator by x plus 5. So if I multiply the denominator by x plus 5, I've got to multiply the numerator by x plus 5. Okay, so now x plus 5 times x plus 5 here, we're going to use the full method. And so this will give me x squared plus 5x plus 5x plus 25. Okay, now let's gather all these like terms together. Okay, the denominator's not going to change here. Okay, so now x squared and x squared is going to give me 2x squared. Now, x squared plus x squared is not x to the fourth. Some of you guys put x to the fourth on your paper there, on your practice test. Now, x squared times x squared will give you x to the fourth. Okay, x squared plus x squared is just 2x squared. Now, notice what's going to happen with a lot of the linear terms here. Negative 5x and 5x is just going to go away, and then the same thing for those two. And now we got 25 and 25, which would be 50. Now, this was the correct answer. Now, if you wanted to, you could factor, but nothing's going to cancel out if you factor. So we could write it this way. We could factor out a 2, and this will leave me with x squared plus 25. And what some people tried to do here was they tried to factor x squared plus 25 and go to canceling stuff out. But x squared plus 25 cannot be factored. It is not a difference of squares. That's a sum of squares. So you can't factor x squared plus 25. So that wasn't necessary to factor on this one. And this answer is just fine. Okay, let's go to number 2 now. So number 2, this is a subtraction problem. So we went over this part in class here that we never subtract rational expressions. We only add the opposite. So if I add the opposite, this means I would say plus a negative x plus 4 there. Now, we're changing it to addition. Now, there again, to combine them together, we need a common denominator. And what's going to be a lot easier to do to get a common denominator here is to factor these denominators out. So let's factor here. Factors of 25 that add to give me 10 would be 5 and 5, and both signs there are going to be negative. So that's just going to factor to x minus 5 times x minus 5. Okay, so I'm just going to write that instead. And now on my second one there, we can factor out a 2, and so that would be 2 times x minus 5. And so let's just put that there instead. So when we copy that down, we probably want a factored form. Now, there again, if we're adding, we want a common denominator. Okay, so this has both monomial factors and binomial factors. So we got a monomial factor of 2. Now let's look at binomial factors. So with binomial factors, we look at what's in common and then what's left over. So they have an x minus 5 in common, but then they also have an x minus 5 there that's left over. So what I saw a lot of when I was grading your papers here, a lot of you guys only just had this. Well, you had one pair of x minus 5s, but then you had this one left over. So I'm going to need both of those right there. Okay, now let's go through and let's modify my numerator. So from here to here, to get that common denominator, I would have had to multiply that denominator by 2. So I'm going to multiply the numerator by 2. And so that's going to give me 2x. Now when I go from here to here, I'm going to have to multiply, notice, by another x minus 5 down there. So that means I need to multiply my numerator by x minus 5. So I have to multiply now this negative x plus 4 times x minus 5, and so I'm going to use the full method. So first here, negative x times x would be negative x squared. And then negative x times negative 5 would be positive 5x. And then 4 times x would be 4x. And then 4 times negative 5 would be negative 20. Okay, now let's clean all this up. So I'll put it in standard form, and we'll put that one first. Now let's combine our x's here. So we got 2x, 5x, and 4x would be 11x. And then we'll bring down the minus 20. Okay, and now notice why I'm writing the denominator, that there are no factors of 20 that are out. They're going to add and subtract to give me 11. So there's no way that anything is going to cancel out. So I don't really have to factor anything or cancel out anything. So this is my answer. Okay, on number 3 and 4, what we're looking at there are complex rational expressions. So the idea on these problems here is to multiply the top and bottom by the least common denominator. And again, the reason why I can do that is because if I do the top and the bottom by the same thing, it's going to get rid of all the fractions. Okay, if I do it by the least common denominator. And so if the least common denominator is, say, a number like 5, if I multiply the top and the bottom by 5, really what I'm multiplying by here, 5 over 5, is just 1. And so that's what makes it legal. Even though it's not an equation, I'm still multiplying by my common denominator. And what makes it legal is I'm doing it on the top and the bottom, which makes it essentially a 1. Now, on this problem, probably what we should see is that x squared minus 9 here at the very bottom here could be factored into x plus 3 times x minus 3. So let's write it like that. And so now that I see that, I should be able to tell here that my least common denominator would be x plus 3 times x minus 3. Now before we start multiplying, let's do this. We never subtract rational expressions. We only add the opposite. Now we're going to go through and we're going to multiply each of these 3 terms by that common denominator, which was x plus 3 times x minus 3. Okay, so now it should get rid of all the fractions. So x plus 3s are going to cancel there. And so that leaves me with 2 times x minus 3, which would be 2x minus 6. Now my second one here, these x minus 3s are going to cancel. And then negative 2 times x plus 3 would be negative 2x minus 6. Okay, and on my denominator, pretty much everything kind of goes away there except for the 5. Okay, now let's clean it up here. Let's get our like terms together. Notice that 2x minus 2x is just going to go away. And now I've got negative 6 minus 6, which is negative 12. So this will be negative 12 over 5 there. Okay, our next one here, I think almost everybody got number 4 right. Let's look through it just in case here. So notice the only denominator that's in the problem is just those x's there. So the least common denominator is x. But there again, we have to multiply every term by that, not just the fraction ones. There again, that's legal because x over x is 1. All I'm really doing is multiplying by 1 when I do this. So now 7 times x is 7x. And now these x's are going to cancel out, and that's just going to leave me with 1. 2 times x is 2x. And minus these x's would cancel out, so it would just be minus 1. Notice I really can't factor anything there. So since the operation is not multiplication, I can't cancel out those x's or anything like that. That's my answer. Okay, number 5, now we're switching to absolute value. Nope, that's not absolute value. Rational inequalities. So notice this one was already set to 0, and it was a single fraction. Now, we'll kind of think ahead on this one. On number 6, it was not set to 0, and it was not one or a single fraction, okay? And those are the first steps, and that's where a lot of people missed it. They actually got number 5 right and missed number 6. So let's review these first 2 steps that even though they don't apply here, let's look at them. So first thing is you set it to 0, and then the second thing here is you want a single fraction, which basically means that you're going to have to combine something together, and so you're going to have to find your least common denominator to do that. Now in this problem, those 2 things are already been done, so it wasn't a big deal, and that's probably why we really didn't miss that. So let's go over how we do these problems here. So we find our critical points here, and our critical points is what makes the numerator and the denominator 0. So what makes the numerator 0 would be a positive 9, and what makes the denominator 0 would be a positive 5. So we put 5 here and 9 here. A couple of people got the numbers backwards there. See, that wouldn't work because 5 is less than 9. So it's got to be that way. And now that gives us 3 intervals here that could be possible solutions. So we label them A, B, C there. And so now what we're going to do is plug them in, plug numbers that are in those intervals into my inequality up there. So with A, a number that would be in interval A here would be like the number 4. So let's plug in 4, and all we have to do is determine if it would be positive or negative. So if we plugged in 4 here and here, 4 minus 9 would be negative, and then 4 minus 5 would also be negative. And now this is supposed to be greater than 0. So if this is true, that means A is going to be a solution for me. So a negative over a negative, though, is a positive. And a positive would be greater than 0. So the interval A is a solution. So we'll shade it in. Now, this said just greater than, so that means 5 here has to be open. Now, let's do the interval B. So in interval B, we're looking for something here that's in between 5 and 9. So we could say, I'm going to just say 6. So now let's plug in 6 and see what happens. So up there, 6 minus 9, that would be negative. And then 6 minus 5 would be positive. And so a negative divided by a positive is a negative. And so we have a negative is greater than 0, and that's not true. Okay, so interval B, the numbers in between 5 and 9, don't work. Now let's try interval C. So a number that we could pick over here for interval C would be possibly 10 or something bigger. So let's plug in 10. 10 minus 9 would be a positive 1, so positive. And then 10 minus 5 is also a positive. And so positive over positive is positive, and a positive is greater than 0. So that interval C worked, and then interval A worked. Okay, and there again, since it's just greater than right there, it's not greater than or equal to, that's going to be open at 9. Now, for my final answer here, it asks for this in interval notation. Okay, so in interval notation, some of you guys actually did the number line right, and then you didn't write the interval notation for it. So be sure you write the interval notation. It'll be negative infinity to 5. And notice I'm using parentheses because they're open circles, and then union 9 to infinity. Okay, now let's look at 6. I think almost all of us had missed number 6. There's a couple people that got it right. So kind of go back to these steps on this one. Notice that this one is not set to 0. Okay, number 5 was set to 0 here, so it wasn't a big deal. So I've got to do this first step on number 6. I have to set it equal to 0. So we get x plus 1 over x minus 1, and we'd say minus 2 is less than or equal to 0. Now, the next thing here, a lot of you guys did critical points like -1 and +1, and we can't do that because it's not a single fraction. You still now have this minus 2 over there, and so we have to combine what we've got right here by finding a common denominator to get a single fraction. So if I looked at this as like minus 2 over 1, then my common denominator would just be x minus 1. And so from there to there, nothing really changed, so we would just bring down x plus 1. Now, when we went from 1 to x minus 1 there, we would have to multiply by x minus 1 to make that happen. So I would need to multiply the numerator by x minus 1. So now let's multiply -2 times x minus 1 would be -2x plus 2. A few people had minus 2 right there. They didn't think a negative times a negative there, and that would give you a positive. All right, now let's clean up that numerator. So you'd say x minus 2x there would be -x, and then 1 and 2 would give me a +3. And now finally, it's a single fraction. So now it's more like a problem like the problem that you had in number 5. Okay, so from here it's not too bad, especially if you had got number 5 right. All right, so now let's get our critical points. That makes the numerator and the denominator 0. So what would make the numerator 0 there is if x was 3, and then what makes the denominator 0 would be 1. Okay, so now we've got some intervals here that we're going to test. So let's start off with interval A. So I think a good number there to test would be 0. Let's plug in 0. So if we plugged in 0, 0 plus 3 there would just be a +3. And then 0 minus -1 would be a negative. And so we've got a positive divided by a negative, which would be a negative. And a negative is less than or equal to 0. So interval A is going to work out for me. Now let's talk about the endpoint right there at 1. Whether or not right here, if it's going to be opened or closed. So this does say right here, less than or equal to. So a lot of times when we say less than or equal to, that means we included or we put a closed dot. But we can never put a closed dot, or we never can include a value that would make it undefined. So let's ask a question here. Does 1 make the function undefined right there? And that would be yes, it does, because it would make me divide by 0. So even though this says less than or equal to, I cannot include 1 because it makes it undefined. Now, let's look at interval B. Okay, so let's pick a number in between 1 and 3. So a nice number there would be 2. All right, let's plug in 2. All right, that's going to be -2 plus 3 would be a positive number. And then 2 minus 1 would be a positive number. So we get a positive divided by positive is less than or equal to 0. Now, positive divided by a positive there would just be a positive. And a positive number is not less than or equal to 0. So interval B is not working out there. So interval B is not a solution. Now let's try interval C. So a number over here would be like 4. All right, let's plug in 4. So now we get -4 there plus 3 would be a -1, so that would be negative. And then -4, I'm sorry, I said -4. That should be just +4 minus 1 would be a +3, so it's just positive. So we have a negative divided by a positive, which is a negative. And sure enough, a negative is less than or equal to 0. So interval C is working out here. So we're going to color in interval C. And now let's talk about the endpoint there at 3, whether or not this needs to be an open or a closed circle. So it has equal to, and so we're probably thinking it's going to be a closed circle. And so I can include it as long as it doesn't make it undefined. Now, 3 would make the numerator 0, but not the denominator. So that means we can include it because it doesn't make it undefined. Okay, now let's put it in interval notation. Okay, let me scoot this down right here. All right, so in interval notation here, left to right, this is going to give me negative infinity to 1 with a parenthesis, and then union. Now I'm including 3, so I put a bracket with 3 to positive infinity. Okay, now let's look at the ones that were on the back. Now everything that was on the back was some sort of an equation. And in each of these, you had to be sure that you didn't have any extraneous solutions. And so anytime you have rational equations, you can't divide by 0. Anytime you have radical equations, anytime you have to square both sides, you have to check for extraneous solutions. Now, let's do number 7 here. And so it just has one radical. So just a reminder here how to solve the radical equations. So if it's just one radical, we isolate the radical, and then we undo it. Okay, so let's do that here. So notice this one is not isolated. We've got the +2 that we've got to do something with. So we're going to subtract it over there to the other side here. So that would be x minus 2. And so now it's isolated. Now we're going to undo the radical. So the way that we undo the square root is we do the opposite and we square it. So we'll square both sides. And so that's going to undo the radical. And when we square this side, this is when we say x minus 2 quantity squared. So we have our shortcut. Now, some of you are struggling with a shortcut. I know you are. Some of you guys need to do this. You need to just take that and you need to fall it out. Okay. Now I'm going to do my shortcut here, though. I'm going to say square, square, and then twice the product. So square and square. Now, twice my product here. My product would be negative 2x, and then doubled would be negative 4x. Okay, so what we end up with now is a quadratic. So since it's a quadratic, we're going to set it equal to 0 and solve it by factoring. Now, I'm going to put everything on the right side because I want to keep x squared positive. It's easier to factor it that way. So I'm going to get rid of this on the left side here and pull it over here to the right side. So now we're going to get 0 equals x squared minus 6x plus 5. And notice that's going to factor pretty nicely here. Factors of 5 that add to be 6 would be 5 and 1. All right, both signs are going to be negative. And so my solutions here, I'm going to get 5 and 1. Now here again, I'm going to have to check for extraneous solutions. So you could go all the way back to the top there to the original problem and plug them in to make sure that they work. Now, if you only have a single radical, there's the shortcut. And the shortcut is to go to the isolation step, which was the second step here. So we'll take away those squares and think if I take the square root of something right there, then this result over here has to be positive. So if x was 5, 5 minus 2 would be a positive number. So 5 is going to be okay. But if x is 1, 1 minus 2 right there is going to be negative, and the square root of something cannot be negative. So 1 is extraneous solutions. You have to mark it out, and we're going to circle that one. Okay, now number 8, instead of having one radical, we've got 2. So this one makes things a lot more complicated. So with 2 radicals, we want to do the opposite here. We don't really want to get them on one side. We want to get them on opposite sides. So what we're going to do is take this one, since it's the negative one, and pull it over to the right side. So we're going to get the square root of 3x plus 1 equals 1 plus the square root of x plus 4. Okay, so now that we've got them separated, now we're going to try to undo them. And so to undo them, we're going to square both sides. Okay, so when we square the left side here, that's just going to undo the radical and give me 3x plus 1. And now here we go again with square, square, twice the product. So square, square, so it's going to be 1, and then plus x plus 4, okay, which is not too bad. Now, twice the product. Now remember, instead of multiplying the 2 and then doubling, you could always just multiply that by 2. And so 2 times 1 is 2. And then I'm going to say 2 times the square root of x plus 4. So it would be plus 2 square root of x plus 4. Now, let's clean all this up on the right side here. I'm going to put 1 and 4 together, and that's going to give me 5. All right, and so now we're down to an equation here. We got rid of the radical over here on the left side, but then we're still stuck with this one on the right side. So now we've got an equation with one radical. So we're going to isolate it and undo it. Okay, so let's isolate it. So we're going to get rid of this 5 on this side and get rid of this x. So now that's going to leave me with 2x plus 4 equals 2 times the square root of x plus 4. Okay, now we've had this discussion about getting rid of this number. So we say we're going to get rid of it as long as it divides out evenly. And notice it would divide out evenly on both sides. So let's go ahead and get rid of it. You don't have to get rid of it. It's going to make this problem easier. So let's do it this way. When we divide the right side, we divide both of those. Okay, so now this would just leave me with x plus 2. Okay, now we got the one radical isolated. Let's square both sides. Okay, so here we go again, square, square, twice the product. That would be x squared plus 4x plus 4 equals x plus 4. Okay, now it's another quadratic, so we're going to set it equal to 0 and probably solve it by factoring it. So we'll subtract that x over. That's going to give me 3x there. And I just caught a mistake. You guys probably realized it when I did it. Go back to here. 1 minus 5 would have been negative 4. And so negative 4 divided by 2, that's going to make that say minus 2. So twice the product there is going to be negative 4x. Okay, sorry about that. So that's going to give me right there. That's not going to be 3x. That's going to be negative 5x. And now let's subtract 4 on both sides. So that's just going to be 0, so it's going to go away. Now I'm left with this, which is kind of confusing because it's not a trinomial, but what I have to see is I can factor out a common factor of x. So we get x times x minus 5 equals 0. So what makes them 0 here would be 0 and 5. Okay, now with checking for extraneous solutions here, there's no shortcut. You're just going to have to plug in the 0 and 5, and you're going to have to go all the way back to the very beginning here. So let's do the 0 first. So I'm going to be plugging in 0. So 3 times 0 would be 0, and 0 and 1 would be 1, and the square root would be 1. 0 plus 4 would be 4, and the square root of 4 is 2. And so I've got left 1 minus 2 equals 1, and that's not correct. 1 minus 2 would be negative 1. So 0 here ended up being an extraneous solution. A lot of you guys got this one. Y'all had 0 and 5, but you didn't mark out 0 as being an extraneous solution. Now let's check 5. Okay, so now let's plug in 5 for x right there. 3 times 5 would be 15. 15 and 1 would be 16, and the square root of 16 is 4. Right, now here, 5 and 4 would be 9, and the square root of 9 would be 3. So we got 4 minus 3 equals 1, and so that one works out. So you got 0 was an extraneous solution, 5 was the real solution. Okay, now the rest of these were rational equations. And what I have to worry about with rational equations as far as extraneous solutions is I can't divide by 0. Now, you're not going to have a possibility of extraneous solutions in number 9 because all you have in the denominators are just numbers. So the denominators would never be 0 there. But in number 10, I'm going to have to be careful here. I can't get a solution of a positive 4. If I get positive 4 as a solution, then really there's going to be no solution. And for number 11, I couldn't get x as a solution because x can't be 0 there. That would make me divide by 0. And like on the last one, we couldn't get a solution of -3 or a solution of +2. And so if I had one of those solutions, again, it would be a no solution problem. All right, now let's go back to number 9. Let's work these. Now my strategy here with an equation, it's different from adding and subtracting. It's actually easier. What we can do is multiply through by the common denominator. So now if we have a 3 and a 2, the common denominator here is going to be 6. So I'm just going to multiply through by the common denominator of 6 and get rid of all the fractions. Now, I didn't do what I should have done first. We're going to change this to say, instead of subtracting here, we always add the opposite. So this will be plus a -4 and then -4 right there. A lot of you guys didn't change that right there to -4, and that's why you missed it. Now, let's go ahead. Let's do some canceling here. 3 goes into 6 2 times. We're now left with 2 times x plus 6, which would be 2x plus 12. 6 times 9 there is going to be 54. And now the next one here, 2 goes into 6 3 times. Negative x times 3 would be negative 3x. And then -4 times 3 would be -12. And now I'm really left with an equation that's pretty solvable. I'm going to gather up my like terms. So let's see, 54 minus 12 would be 44. That's not right. That would be 42. Yeah, that's better. Now, let's get our like terms together, or get our x's over here on the left side. So I'm going to add 3x to both sides. That's going to give me 5x. And we'll subtract 12 from both sides. And that's going to give me 30. And so 30 divided by 5 there is going to give me 6. And notice it's perfectly okay if x is 6 because it's not going to make me divide by 0. That's where I got to check for the extraneous solutions, to make sure that we don't divide by 0. Okay, on number 10, now there's only one denominator or one type of denominator here. It's x minus 4. So the common denominator is just x minus 4. So we're going to multiply through now by x minus 4. So those will cancel. That's just going to give me 4. 3 times x minus 4 would be 3x minus 12. Again, those cancel out and just leaves me with plus x. Now let's solve what we got left here. I'm going to put 3x and x together. That's going to give me 4x. All right, let's add this 12 over. So that's going to give me 16. And then 16 divided by 4 is 4. So it looks like 4 is our answer, but this is why we have to check for extraneous solutions. If x is 4, that's going to make me divide by 0. So 4 ends up being an extraneous solution. So what happened in this one? This one was no solution. A lot of you guys had 4 for your answer, but you didn't mark it out as an extraneous solution. So there's really no solution to this problem. Because if x is 4, I'm dividing by 0, and I can't do that. Okay, number 11. Now let's check out our denominators here. We've got x, 3x, and then 9. So I have a 1, a 3, and a 9. 9 would be the common denominator, and we'll put an x along with that with the lowest power there. So we got 9x. That's the common denominator here. We're going to multiply every term by that. And let's go to canceling. So the x's will cancel out there. 2 times 9 is 18. And then the next one there, 2 times 9x would be 18x. And the next one here, 3 goes into 9 3 times. and the x's would cancel. So 2 times 3 would give me 6. And then those 9's cancel. That's going to give me 19x. Okay, now let's get our terms together on one side. I'm going to put my x's on the right side over here. That's going to give me x. Subtract 6 on both sides. That's going to give me 12. So we get x is 12. Now let's make sure that that's not an extraneous solution. So if x is 12 there, is that going to make me divide by 0? It wouldn't. The only thing that would make me divide by 0 is if x was 0. So 12 here is an okay solution. It's not extraneous. Okay, the last one, number 12. First thing, we never subtract rational expressions. We always add the opposite. Now, it's going to be a lot easier to find the common denominator here if I can factor this over here. So factors of 6 that subtract to be 1 would be 3 and 2. So they're going to be different signs, plus we're going for the bigger number. So plus 3 minus 2. So let's put that there instead. Okay, so that makes my common denominator x plus 3 times x minus 2. So we'll multiply everything by that. And again, I can do this because multiplying by the common denominator, I can do an equation because what I do to one side, I can do the other. Now, let's go to canceling. Now that leaves me with 6 times x minus 2, which would be 6x minus 12. X minus 2's cancel here, so that would leave me with negative 5x minus 15. There again, if you didn't say plus a negative 5 right there, you probably missed that sign in the problem. Now, on my right side here, pretty much everything's going to cancel out and just leave me with negative 20. And so now I've got something that's really solvable here. I've got 6x minus 5x would be x. Negative 12 minus 15 would be negative 27. And so now let's just add 27 to both sides, and that's going to be a positive 7. Okay, so let's notice is if x is 7, would it make me divide by 0? So that wouldn't be 0 if x was 7, and that wouldn't be either. And these two would not be 0, so it's not an extraneous solution. It's an okay solution. Now there again, if we have some trouble with this still, this is going to be, I'm going to email you a link here to put this video on YouTube that you can go back and look at tonight. And since we've got some time here, the next slide here I'm going to show you is just give you a few practice problems here. Okay, so here's some practice problems here. If you want to just take a look with some extra practice. The next slide, or I'm actually going to write in the answers here. I'll pause them and work it out. And so you can have the answers. So if you want to pause this and write these down right now for some extra practice, that would be a good idea. Okay, I believe those are going to be, what's in red now would be the solutions. Those just little 3 extra practice problems there if you wanted to try.